This video is going to discuss Newton's laws of motion. Students will be able to recite Newton's 3 laws of motion. Let's begin. Newton's first law of motion states, an object in motion will stay in motion and an object at rest will stay at rest unless it is acted upon by an unbalanced force. In other words, objects are going to keep doing whatever they were originally doing unless something actually changes that. As an example of this, a space probe is moving through distant outer space, out in the vast nothingness of space, at a speed of 200 meters per second when it runs out of fuel. What happens to its velocity? Does it A, begin to speed up, B, begin to slow down, C, begin to change direction, or D, that its velocity doesn't change at all? If you said B, that it begins to slow down. This is typically like if you had an airplane on Earth and it ran out of gas or jet fuel or whatever it's running on. Eventually it would slow down. Air resistance gets in the way, that kind of stuff. But in space there is no air. So that's not the right answer. There's nothing there to slow it down. So objects will keep doing whatever it is they're doing. So it'll just keep going at the same speed or velocity. Newton's second law of motion states that an object's acceleration is directly proportional to the force acting on it and inversely proportional to its mass. This is a fancy way of saying that more force will make it accelerate and more mass will make it accelerate less. So the more mass something has, the less it will accelerate with the same amount of force, and putting more force on something will make it accelerate more. For example, if the force acting on an object is tripled, by what factor will its acceleration increase? In other words, how many times more will the acceleration be if the force is 3 times as much? If you said that the acceleration would triple, then you would be correct. Since an object's acceleration is directly proportional to the force acting on it, tripling the force would triple the acceleration. That's what it means to be directly proportional. Newton's third law of motion states that for every force or action, there's an equal and opposite reaction force. This means if you push on something, technically it pushes back on you with the same amount of force. And it's equal, meaning it has the same amount or magnitude, and opposite, meaning the exact opposite direction. So if you're pushing something to the right, it pushes back on you to the left. All of the following situations can be explained using Newton's third law, except for one of them. Which situation cannot be explained using third law ideas? A says an inflated balloon is not tied and is let go. It moves forward as it pushes air backward out of the hole. So since it's pushing air back, that makes the balloon move forward. That sounds like action and reaction. So that can be explained using Newton's third law, which means it's not an answer to this question. The gravitational interaction between Earth and the Moon affects both objects, with Earth's tides mostly due to the Moon's gravitational pull. So that sounds like the Moon's pull causes the tides to be moved, and vice versa. So that sounds like action and reaction, which means this is a third law thing, which means it can't be the answer. C says a projectile's horizontal velocity remains constant because gravity is a vertical force and no horizontal force acts on the projectile. We know that's true from two-dimensional motion. I don't know if I can relate that to a third law. Let's move on to D. D says a propeller airplane would not work in outer space because the propellers would work normally by pushing air backward to move the plane forward. That sounds like the air from the air in the balloon from question answer part A. So I don't think that's the answer either. That sounds like a third law thing. That only leaves C. This just talks about two-dimensional motion. This isn't dealing with Newton's third law. So to recap, please take the questions and complete the questions on Edmodo after taking these notes. Bring your notes with you to class next time to help on the Open Note quiz. And thanks for watching.